Maybe. We're really slow today. There we go. Okay, so we talked, well, I talked, you listened yesterday, about limits involving infinity. Infinity is not a number, which is so weird, especially considering what we're going to do with it today. We're going to treat it like a number, which is really bizarre. So we're going to actually talk about doing math with infinity today. This will not be on this round. So anyway, that's what we talked about, or you talked about yesterday. Limits involving infinity. So what we're going to talk about today is limits involving infinity, but how do you do a limit algebraically if it involves infinity? So algebraically means you're not using the graph. This is 11.3 part 2. And so we're going to, yes.
Is this going to be on a quiz?
Not on this quiz. It might be on the next quiz.
Yeah, we have a quiz.
Oh, quite possibly.
Next quiz.
Most of you are waiving my exam. Why would I not just continue teaching?
Because I don't want to take a quiz and an exam.
Javon just likes to whine, so.
A little bit, but it's also valid. Because everybody else will waive it. So then I should not take a quiz.
What? Dude, just waive this exam if you don't want to go on taking it. I don't know.
I'm going to use them on this class.
Then quit complaining.
Then quit complaining.
No, what's ridiculous is the amount of times you complain in this class. That's what's ridiculous.
Yes. Okay, so here's what I want you to do. Let's, I'm going to have you come up here, and I want you to draw one infinity on the whiteboard. Yeah, just draw one. You guys have been drawing them, so, and then put your initial next to it. Okay, so. Oh, too bad.
Yep.
Right, yeah.
Do I get to use the pen?
Yeah.
Can I redo it? Can I redo it?
Those are two names that
Do I get one shot or can I erase it?
One shot, do it.
Wait, I followed it.
Yeah,
Guys,
Carson.
I need to do my city.
This is what we were practicing for yesterday.
This is what you were practicing for
I'm
yesterday.
over here practicing, but I can't really.
Okay, that's
Okay, that's not bad. Andy, that's.
Oh, nice. No, Kira, you can't erase it. Kira,
No,
hey,
Kira.
cheater. Ellen, you gotta go draw it.
I will, but why would I go draw right now while everyone else is drawing?
Because everyone else is drawing. So it's up there. Get out of
We're
here.
going out, guys. I have some, this is a
Oh,
handout.
Jesus.
There's 4 pages of vocab I haven't done yet. My test is
For what?
for econ, bro. Mr. Bishop doesn't like it.
You like dying? Yeah, Sean.
I mean, if you didn't have Mr. Bissy,
Whoa.
this would be fun.
Can't erase that.
Oh,
I can't multitask, guys.
that's the best one. Okay, so here's what I'm going to tell you. There was one year, it was a long time ago, that I went to a training. I still have the papers. Like, it was all about drawing infinity. Okay, so there's some scientific research. So listen.
I need to go to that.
No wonder
Here you
you're just so good.
There's, whoa, she's like about to go philosophical.
So here you go. Drawing the infinity symbol, which is also figure 8 sideways, right, is considered a foundational exercise for brain integration. Ooh, that sounds brilliant. Okay, so here's why. Listen, this simple activity engages both hemispheres of the brain because you're going, anytime you go across your body, right, you're going across, it's good for your brain. So it says, promotes better coordination and communication between them. As you draw, the brain must synchronize movements and processes, enhancing cognitive flexibility and balance.
Ellen doesn't have a lot of that.
Do not.
Here you go. This practice improves hand-eye coordination, fine motor skills, and spatial awareness. Additionally, the repetitive flowing motion of the infinity symbol can have a calming effect, reducing stress and fostering mindfulness. Overall, integrating exercises into daily routines supports cognitive development and overall brain health. Is that exciting? Like, if you are like, I'm bored, you can calm yourself down by drawing infinities. But-
Why did someone choose to study this?
I don't know. Here you go. But this one says, this is literally about, like, how you draw your infinity tells things about you. Okay, so that's why we're drawing. So,
Yikes, guys.
if you're,
What kind of special is that one?
I don't even know. Cause it's not even an infinity, I don't even know what it is. So if you have, here you go, I'll put this up on, well, I don't wanna put this up on the screen. So if your infinity is nice and symmetric, okay, it's really symmetric, then that means, you are a very well-rounded individual. Wow. We got that. Okay, so look at this one's pretty good. This one's pretty good. This one, Andy, is very interesting. That's what we're gonna psychology on Andy here. Okay. So what we'll talk about the imbalance. This one, with the top, says that like when the cross is more at the top like that, you may be more of a kinesthetic learner, like likes learning hands-on. This could all be just crap, so that's all I'm saying. It's just what my thing says. Arkin's a little bit left balanced there. I don't even know. Alan's looks like half a pretzel that somebody ate. I don't have
There's gotta
that.
be
I have
something
too
there.
much going on in my head right now.
Okay, so if it's left heavy, so if the left side is heavy, there's a lot going on in your head that you're not saying. Like you have inner dialogue and feelings. You're keeping it inside. Nobody's really left heavy. If it's diagonal,
Larson, what do you hold it, dude?
not much, yeah. Christian's is a little like this. It says more visual construction. I don't know what that means. Less visual memory and more inner dialogue. So you got a lot going on in the head.
Oh, yeah.
You
I
talking
don't
to
know
yourself?
if that's
In
necessary.
there all the time.
This is really long.
I would say the second one is correct. I don't know about the third one.
If you have like Eli's is skinny like that and fairly symmetric, it says strong listening to others.
Eli, look at you.
Are you a strong listener, Eli? Yeah.
Mine's
Yeah,
pretty
good
close
story.
to
Nobody really has this, but if it's a smushy skinny one, it means you have difficulty listening to others. So the long one is
Javon, where's Javon's?
Oh no, this is actually.
You're the one that's up down. I don't wanna hear it. You went up there and do a pretzel. You didn't pay attention.
Okay, so we got, no, that's not that one. If it's a left heavy like that, it does say you're more right brain oriented, stronger spatial and emotional emphasis.
What one is that?
It would have to be like big on one side like that. Which
So
one?
like Andy's kind of.
Except Andy's is opposite, right? So if it's big on the other side, Andy's is more left brain oriented, stronger emphasis on sequence, analysis, and controlled movement.
I'm very controlled.
Very controlled. And the rest of these, like, they're all the fairly well-rounded ones, like, don't really pull you. It says you have access to all the sensory modalities. What is a sensory modality? I don't know. Just makes you well-rounded, that's what I think. Again, I'm sorry, I don't know what Ellen.
Yeah.
You might wanna go.
Why don't we give Ellen a retry?
Special category.
You wanna retry?
I forgot how to do it now. I don't want to go back up there.
You draw a figure 8.
Do it.
Oh.
Make her go back up there.
Do it.
Make her. She has to.
Well, here, let me see your homework.
We gotta analyze Ellen right now.
We'll analyze Ellen, I'll look at Ellen's homework and we'll see what Ellen's. She definitely has left heavy ones.
What's your inner dialogue, Ellen?
Yeah, you got lots going on in your head?
Like, if I try to draw.
Econ is going on in Ellen's head. And they tend to the bottom of it, so I don't remember what that was. Maddie's was on the top, and let's see. Yours is a little bit on the bottom. I still think this is probably just a bunch of crap.
Yo.
But, visual learner.
So these are mine.
Do you think you're a visual learner?
Are they so small?
I don't know. Okay, anyway, like I said, I have no idea. I feel like this probably is a load of crap, but it makes me giggle when we talk about it, so we talk about it. So, we're
That's a
writing
good one, but that's scary.
lots of infinities today. So what we're gonna do is talk about finding limits with algebra. Okay, so then we end up with this really weird idea of the fact that infinity is not a number, but we are going to be treating him like he is one. Okay, so that's weird. So I gotta find my notes just a second. Yeah, which means it will be meaningless to anybody that didn't see that.
Yeah.
Yep, so good times.
Nobody can see Ellen's pretzel.
You could draw it on the paper for him.
You could draw it. You should recreate Ellen.
Oh, that's okay.
I'm good, guys.
The thing that I don't understand, the thing that I don't understand is if I were to draw 100 infinities, I probably would get one of each of those in there. So that's why I think it's probably a lot
They
of crap.
probably were doing a scientific study on you guys to see if they taught you something like you'd actually believe it. Is that what you did?
Probably. It's
It's
probably just a. Yep.
Oh, they're bringing back the microwave. The funniest thing is when you see a kid wipe out.
Okay. So here we go.
Poor kids, yo. You got too much empathy here.
What do you mean too much?
I mean, you got too much empathy.
This is a big word. She's a very kind person with some compassion. Weston. Wrong direction. Okay.
North End.
North. At least I didn't come up with that one. Okay, so here's this. What's the first step? What's the first step for any limit problem?
You gotta plug in for infinity.
You want to plug it in. So the problem is, if infinity is not a number, how are we plugging it in and what the heck?
Log in.
Okay, no, you're not logging it.
Don't say that word.
What did you say? Put a bunch of 9s in for every one. So essentially, Christian is not on the wrong track. You're going to think about, he's not on the wrong track. So you're going to, basically this is thinking, okay? Thinking math. Oh, stop. So I want you to think about this. If I have the biggest number you can think of and larger, and I square it, so if I have infinity squared, what is that going to be? It's going to be infinity, right? And then if I multiply 3 times infinity, what's that going to be? Infinity. And if I add infinity plus infinity, it's still infinite, right? And then if I add 4, it's still infinite. Okay? So,
It's 1.
Infinity over infinity.
Infinity divided by infinity.
okay, so the bottom one is also going to be infinity. Because we are squaring, then we're subtracting infinity, and then we're adding 2. It's still infinite. Okay, now, this is not 1. Okay, this is not 1.
It's infinity.
Nope, it's actually indeterminate.
Because you don't know what numbers are plugged in.
Exactly. This is indeterminate. So, our other indeterminate form was 0 over 0, right? 0 over 0. And 0 over 0 indicated that there was what? A whole. Okay, this doesn't really tell us anything like that. It does tell us, no. It does tell us we have to do something else. Okay? So with this indeterminate form, we have to do something else. But listen, because this is infinity, there's only one thing you do, and you only do it when it's infinity over infinity. So this does not add to that other bunch. Okay, this is its own separate rule. So when it's infinity over infinity, you divide all the pieces. Well, let's go this. The top and the bottom. You divide the top and the bottom by the highest powered variable in the denominator. I'll show you. Okay, so this is, you divide the top and the bottom by the highest powered variable in the denominator. Okay, so what's my highest powered variable? X squared. So not the 2, just the x squared, so just the variable. Okay, so we're gonna come through and we're gonna divide. You can write this however it makes you happy, okay? I just like to divide all the pieces by x squared. Like I literally am gonna come through and write all the pieces. If you wanna just write over here, you're dividing by x squared over x squared because that's what you're doing. That's fine too. X squared divided by x squared is what? 1. And so we're dividing by 1. So this is a legal rewrite. Okay, now watch what happens. Okay, we are going to rewrite this because there's no factoring, there's no expanding. The only quote unquote work piece is to divide the pieces by x squared. So what is x squared divided by x squared? 1. Okay, this is a little review of exponent stuff, but if you have 3x divided by x squared, what's that equal to? Okay. So I want you to think about it like this. What did you say? Yeah. Did you say that, Larger? Okay. So look, this is 3x over x squared. One of these x's cancels, and this is 3 over x. 4 divided by x squared is 4 divided by x squared. What? Okay. 2 divided by x squared over x squared is what? 2. Okay, whoops, sorry, that's a minus. So I've got 3x over x squared, which is what? 3 over x. And then I've got a 2 over x squared. Now, you probably sit there and go, this did not make that any better. Okay, so let me... No. Let me introduce you to a couple ideas here. So first of all, I want you to hear me say this. It addresses what you were talking about. I cannot cancel anything top to bottom if there are pluses in there. So it's so tempting to be like, well, I'll just get rid of those. No. If there's pluses or minuses in there.
Will there ever be a time in this where we can cancel?
Top to bottom? No. Okay, so here's what I want you to understand. Let's say I'm a large fan of chocolate. So let's say I have one candy bar. You don't have to write this. It doesn't matter.
It doesn't matter.
No, it does.
Something full of chocolate.
So,
Good
full of
chocolate.
chocolate or made of
Do
chocolate?
buy chocolate.
Do I buy? Oh, no.
No, do buy chocolate.
No.
Do you buy Hershey's?
We're going to go Dove chocolate because that's good.
Like a nice
Milk
German
chocolate
cake.
or
What? Milk chocolate. So if I have one candy bar, so the top is how many candy bars I have. And I am only sharing it with myself. So one person. How much of the candy bar do I get? Okay. If I have one friend and I decide to share that candy bar, how much of the candy bar do I get? Okay. Let's say we're going to not make this take forever. Let's say I have 10 friends.
Well, looks like you're gonna have a candy bar.
I get 1/10 of the candy bar. What's happening to the amount of candy bars, the candy bar I get?
How big is this candy bar?
Good enough.
Well, you don't have to share.
I don't.
That's the size.
Okay. Let's say I have 100 people that I'm sharing my candy bar with. How much of the candy bar am I getting? Javon, just go with the principle. Okay? I'm getting a sliver now, right? Maybe I can have a sliver. Okay? So if I have 1,000 people, I might as well, I now have a crumb.
Just sniff it.
I might, right? Sniff it. Okay, so listen, let's say there's 100 million people that I'm sharing my one candy bar with. Maybe I get an atom of chocolate, right? I get a very small amount. So listen, it doesn't even matter. It basically does.
It's like chemistry now. It just doesn't
Okay,
matter.
it doesn't matter anymore. So listen, let's say I have 1 divided by an infinite number. What is that essentially? This is essentially 0. Now, listen, what if I had 2 candy bars divided by infinite number of people? It's still essentially nothing, right? So here's the principle of this. my next step would be to plug this in. So this would be 1 plus 3 over infinity, 4 over infinity squared, 2 minus 3 over infinity plus 2 over infinity squared. 3 over infinity, based on what we just talked about, is what? So it's just 1 over 2. So here's my thought to you. Don't put this in there because that's just me illustrating the purpose, right? Illustrating the principle. If you have a number, any number, a constant number divided by something infinite, it is 0. Okay? A constant number divided by infinity, constant, divided by infinity is 0. Okay? Because of the principle of the candy bar, right? Essentially, you're getting nothing. It's not even worth anything. Okay? So this is how you do limits with infinity. Okay? So let's do the limit as x approaches infinity of, let's go x plus 4 over x squared minus x plus 5. Okay, so if I plug in infinity, do I get infinity over infinity?
Yeah.
Yeah, because I have something infinite on the top, I got something infinite on the bottom because I got infinity squared, which is ginormous. Okay, so I have infinity over infinity, which is indeterminate. So we know that we have to divide the top and the bottom by the highest powered variable in the denominator, which is what? X squared. X squared. So we're going to come through and divide by x squared. Again, you do not have to write all of these. You can probably do them in your head, and that is fine. But you do have to rewrite this step here. Because I need to know what you're reducing. You need to prove what you're reducing here. So this first one is x over x squared. What is that equal to? No.
Oh, I don't know that.
Where is the x?
1 over x.
Well, there you go. The x on the bottom, right? So this is 1 over x. Okay. Again, if you're like, where are you getting that? This cancels, but x is on the bottom, so you got to keep them on the top with the 1. Okay. 4 over x squared is 4 over x squared. Okay. The bottom, what's x squared over x squared? 1. Minus what? 1 over x. Plus 5 over x squared, nothing cancels. Okay. Now, when you put your infinity in, okay, you've got 1 over infinity plus 4 over infinity squared. That's on the top. And then 1 over infinity, 5 over infinity squared. Okay. 1 over infinity is what? 0. So 0, 0, 0, 0. So we have what?
0 over 1.
What is 0 over 1 equal to? 0.
0.
0 over a number is 0. There you go. So it's not a difficult concept. You just have to have the correct strategy to throw at it. Okay, let's try. We're going to do 2 more and then we'll be done. Let's go the limit as x approaches infinity of x cubed plus 2x over x minus 9. Okay, so first question, is it infinity over infinity?
Yep.
Okay, infinity over infinity. So we're going to come through and divide. What are we dividing by? Divide by x. Yep, just x, because that's the largest power in the denominator. Yes, always in the denominator. So not just the straight largest, but the one in the bottom. The reason that we do that, mathematically speaking, is because that will always give us a number here, and then we will no longer have an infinity on the bottom. If you look back at your notes, we're always creating a number in there. So what's the top? Simplify to? Yep, x squared plus 2. The bottom is
1 minus 9 over x.
1 minus 9 over x. Okay, now you're going to plug in your infinity. And what do you get?
Infinity over 1.
So I want you to think about it. So listen, the deal is that people are like, oh, infinity is just 0. It's not. Okay, it's not 0. This is 0 because that's a number over infinity, but the top is infinity squared. What's infinity squared? Infinity plus 2, still infinity. This is infinity over 1, which is infinity. Nope. Infinity over infinity is indeterminate, but infinity over 1 is infinity. So I want you to think about dividing something infinite. You're going to divide, well, you're dividing by 1, but even if it was infinity divided by 4, that's still infinite. Okay, let's do,
Nice one.
All my papers are
I wasn't fearing.
just in case you were.
okay. Yep. So we're going to do a -1 just so you can see what happens. Okay, so I want you to think about this a second with me. If I put a negative infinity to the 5th power, is that going to be positive or negative? Negative. So this is going to be negative infinity. The bottom is going to be positive infinity. That's still indeterminate. So any form of infinity, any positive and negative combination is still indeterminate. So that doesn't change our strategy. What are we going to do here? Yep. Divide by x squared. So the top is what?
Infinity?
No. We're going to simplify first.
Oh, my bad.
That's okay.
4x cubed.
Yep. Over 2 minus 5 over x squared. Christian did that earlier too. Sometimes it happens to me too. Made an 8 instead of an infinity on accident. It was on your homework, I think. Okay, so when you plug in negative infinity, what are you going to get?
Negative infinity.
You're going to get negative infinity, right? Because it's cubed. So that's just negative infinity. Okay, because it's cubed. If this was 4x squared and we were doing the limit as x approaches negative infinity, then it would be what? It would be positive, right? So you just want to watch. When the negative infinity comes along, it's really just about the sign. Is it positive or negative? So just watch that. Okay, I think that is all that I have for you. Yeah, because she's just told us she was bad at multitasking, and then she's throwing papers on the floor and doing economics. I know. That's the pilot.
We have a bunch of good food at my house, but I haven't been home in like 3 days.
There's a bunch of good food.
Because I looked at the fridge last night and my mom made sweet flour chicken on top of the good food. And I was like, dang, I just ate at Mr. Missy's. I can't eat again. I'm sad. And then Mason starts washing it down at 11 o'clock at night. I'm like,
I would like you may cross off, let's see, you may cross off number 7. And you may cross off 8. And then if you're in the Gold Star Club, you may cross off 1. Okay. So everybody's crossing off 7 to 8. Gold Star Club crossed off number 1.